Hello friends, welcome back to Something of Everything. In this video we will see how to model, analyze and design a structure using RcadExpress, Planwin, Framewin. So we are designing a bungalow, G plus 1 story bungalow with stair cabin above. So we have created structural GA of the same. Now all we will need is to create the arcade columns, arcade beams and placing the arcade slabs, extracting the center line from it. Then importing the center lines in Planwin, adding the beam wall loads, slab loads, creating the 3D frame using Framewin, and then extracting the tables for detailing in RcadExpress. So let's get started. In order to create the center line, first we will select the columns, type ml command to isolate the same. It will isolate the layers of the selected entity. Then we will use a call command to create the columns. Our columns are rectangles, so we are just pressing enter and selecting the columns. Those we will need to make that of arcade. Arcade columns are basically a parametric block. Now we want to create the arcade beams, so we are just using the same commands to isolate the beams, and we will give the beam info by info command. Press the enter, size of the beam and press OK. Now we shall use 111 command to generate the beam. You have to select top lines and left lines to generate the beams. Okay, so we can select window, select the same. And it will create arcade beams. Arcade beams are and slab marking shall be required to generate the center line. As you can see, all the top lines and left lines has been selected, so we just have to press enter to generate the beams. These beams are pending. We shall be using 333 command to generate those beams because we are selecting bottom lines. Okay, now press 161 to on everything. This beam needs to be below, so we are just shifting this beam for model simplification. We shall use BCH command to revise the beam length. Okay, beam shall be between columns. This beam is okay, this beam is okay, this beam needs to be revised by BCH command and the revised length. That's perfect. Here we need this beam to be up to this line, right? So all we have to do is we have to use BCH command, select the object, select the new length. This is the fixed point, so the beam has extended above. We have to shift it. We can delete this and copy this beam. Now we shall need to draw the slabs. Just type ML to isolate the beams and go to slab marking and press SN. Press enter, select the number, text height and just select in between the beams. We have hide the columns because for slab marking we need to select cross, the cursor needs to cross the beams. It will select one way or two way symbol by default based on the aspect ratio. Once the creation of slab marking is complete, all we will need is to go to beam center line and press GLP center line for Planwin. It will ask for column heights, press enter and select all the objects that are just created, and it will generate a center line. As you can see, the center line has been generated. Now we need to place the columns at the locations needed, right? So just press 161 to start the columns, and this slabs needs to be in the slab layer. So we need to change the grid beam layer to slab layer. This needs to be slab layer. So we need to rename the slab layer first. This needs to be slab 1. Then we have to go back to grid beam, and we have to make that slab layer. Now we shall have to create circles in column layer. The Planwin imports columns and slabs with the layer itself. Okay, so let's just type CI and press a column. Just press the columns, draw the columns at the locations where there is a column. This is a wrong column. At this point. So basically we are doing column marking. The same column comes at the above level, so we are just copying it and pasting it to the right locations. We don't want all the columns, we only want these 2 columns for stair cabin, and there are more 2 columns at these locations also from first floor slab. As you can see, in the first floor it is SB, so they will start from first floor slab. So those are the columns for stair cabin only, so we just need to delete it from here. Now this is our reference point, so just put 1 column at the reference point, that is 0 0 0, because you need to have a fixed 0 point so that all the plans comes in line, right? This point has come wrong. This is perfect. Yes, let's just copy this to stair cabin also. Okay, now we have to export these plans to DXF in order to import the same in Planwin. So for that we have a custom command called DXF also. We shall select the objects and we will select the center point. Now this is our plinth level plan. We shall do the same again for the same objects as GF slab level plan. The same command, first floor columns and FF slab level plan. Same command, objects and center point, SC level slab level plan. So this way we have created DXF files for importing in Planwin. Let us now import the plans in Planwin and apply the slab and beam loads. So this is the Planwin window. To import the DXF file just created, you have to go to File, Import and press DXF. Press millimeter or the unit that is that of your DXF file. Press OK. We are selecting plinth level plan to draw. As you can see, the slabs and columns has been generated. This column shall not be needed. We shall change the design parameters to the ground level. The floor height shall be 3.35. The internal walls shall be of 0.115. Concrete steel grade shall be Fe 500, and we will press OK. Now we will generate the beams by using auto beam command. We shall give the size of the beam and we shall give the UDL. As you can see, the self weight, wall load and plaster loads are calculated by default. You will not need calculator to calculate these loads. And for the external also we shall change the beam depth above and press OK. The steel concrete grade shall be 250 and press OK. As you can see, all the beams has been generated. To copy this beam, you can just go to copy and paste. As you know, we do not need slabs because at plinth level there shall not be slabs. So we are selecting all the slabs and pressing delete button to delete the slabs. These beams shall not be there in the plinth level. As you can see, at plinth level this is a washyard. Let us have this beam because this bracket is there. So to confine the same, we are having these beams at plinth level. And at the veranda level, as you can see, there is something called gated veranda. So we are just using beams for the same. We shall need one beam extra at this level. So the spacing of the same shall be 1733. So we shall select this beam, we shall copy it, we shall click on paste, and as you can see, it will give us the distance of 1.733. Press OK. Because we have given the positive number, it has been shifted to the right side. Press Ctrl Z, go to the same, press here and give the distance to negative side and press OK. The new beam has been generated. And in the case of cantilevers, you shall have to modify the property to make it a cantilever beam, otherwise it will generate an error. Go to property, press cantilever, and this shall be cantilever also. Press OK. Now check the continuity of beams. Press continuity of beams, go to analysis. As you can see, all the beams has been completed correctly. Now just run the file. Continuity analysis has been performed without continuity. If you want to perform the analysis with continuity, go to design parameters and analysis with continuity. Press OK with continuity. It has given us the total live load, total dead load, total slab, total beam load, and everything, as you can see. And it also gives us the total beam length. Okay, so from here only you can analyze the floor level plan. Just press save and give it a name of plinth level. Now just import the GF slab level plan. Same way, the same process shall apply for GF slab level, first floor slab level, and stair cabin level. We shall have to delete this column because it is not there. And go to design parameters. It is a typical floor. We shall have the height of 3.35. The steel grade shall be 500. We shall analyze with continuity. Go to beam, press auto beam. The beam size shall be 0.425 and the height of the beam above shall be same. So it has calculated the loads automatically, and we have to press OK. So all the beams of GF slab level has came. You can see the first floor plan. You can remove the load from this internal beam if you want. You can also adjust the load of these walls. This is a continuous wall, this is a continuous wall, so we do not need to change the wall load at any point. If you want to see the UDL, you have to go to description box and press the UDL. You can see all the external beams have been given 17.65 load. All the internal beams have been given 10.58 loads. You have to select all the slabs. To give the parameters to the slabs, you have to click on slab set values. Now you can give the details of the slab. Thickness shall be 0.125, density is OK, floor fin is OK, live load is OK, load direction is OK. Let us see whether it has taken the load direction or not. As you can see, it has taken the load direction by default. This slab shall be one way, so we just have to click on one way, and as you can see, the slab has been converted to one way slab. We have to change the property of these beams to make them cantilever. So you just go to select unselect beams, select the beams that you want to be cantilever, and go to set values, and in the beam type just press cantilever, press OK. Rest seems same. As you can see, for the simply supported beam, that is simple beams, it shall be blue tick mark at the center, and for the cantilever it shall be red tick mark. Let us just unselect all. The slab level plan has been completed. We have to check the continuity first. As you can see, there is a minor error of 0.24, that is neglectable. Press OK, press close, As you can see, all the columns are being given the load that is coming on it from the walls and beams by side. You can just analyze the same, all the columns and everything from here also. Just press close, press the analysis, the same shall come here, press OK, press save. This is our GF slab level, right? We have to create the first floor slab level as well. As you can see, everything seems same except this beam and slab. So we are just save as this beam plan as FF slab level because everything seems same, only there is one more beam here. So we are just copying it, we are just pasting it to this side at minus 1.3733 and press OK. We have to remove the load from it because it is a terrace level, right? So we are just removing the wall and plaster load from it and pressing OK. We have to do the same for all the internal beams except the stair cabin beams, right? So we have to select this beam, this and this beam. We have to set the values of UDL to only the self weight, right? And press OK. For all the external beams, we have to change the design parameter first to roof because height of floor above 0 because it is a roof, right? That seems okay. Select all the peripheral beams. So just unselect all the beams, go to beams and select all external beams. As you can see, all the external beams has been selected. Select the beam UDL, change the UDL. The wall height above shall be 1 meter, that of parapet wall. So it will be just giving SX plus 5.2, that is 7.644. Parapet load has been generated. We have to give the stair cabin load to these beams. So just go to beams, unselect all, go to beams, select the beams. We are selecting these 4 beams, right? Let us just select 2 beams first, give the set values, give to UDL, and the height above shall be 2.915. The wall shall be of 2.30. Press OK, give the UDL of that. And for these beams we need only load up to this, right? So select this beam and go to properties, and the property of that beam has been shown. You have to give the wedge load from this point to this point. So we are giving load W1, distance shall be from this, length shall be up to, the distance shall be from this and length shall be up to this. Load shall be 17.304 minus 2.444 because self weight is there, right? So as you can see, the loads can be seen from here. So we have to give 6.7 this shall be 0.23. So you can directly calculate 13.455 plus 1.404 load needs to be given, that is 14.859 needs to be given. 14.859 and 14.859. Press OK. You cannot see it here, just go to this and click on wedge point load. As you can see, the wall load has been generated up to this line. Do the same for this also. In this case it shall be W2, distance shall be from this, length shall be up to this, and the load shall be 14.859. 14.859. Press OK. As you can see, the load has generated. We have to select all the slabs and change the slab parameter, that is loads, because it is a terrace. You have to give the load differently. The load has been generated. This slab needs to be cut at this beam, right? So we have to go to slab and select all. We have to go to slab and select this slab, and we have to delete this. We shall be creating 2 new slabs. You have to select create irregular slab and you have to give the points. Press OK, press again, press OK, and the slab has been generated, that is of 2.5 by 1.3. The slab shall be this, and you have to change the loads to 1.5. Press OK. As you can see, the slab has been generated. You have to press irregular slab again, select one point, select second point and press OK and click right click, and the slab shall be generated. Two new slabs has been generated at terrace level. These two beams are deleted because when we have deleted the slabs, we have not removed these beam selections. Go to beams and select all kind of things. We have to just press Ctrl Z. We have to select the slab and delete it, and you have to see whether there is no other entity has been selected. Now create the irregular slab, select 2 points, press OK, select second point, press OK and right click and press OK. The slab has been generated. Same way you have to create one more slab, press OK, select the second point, press OK and right click, press OK. As you can see, the slabs has been generated. Let us see the floor finish of slab. All the floor finish has been completed. We have to change the floor finish and live load of this level, because it is a stair cabin. There shall not be the same load, right? You have to check the beam continuity. Click on here. As you can see, it is asking which kind of beam will be this. For our case, it shall be a simple beam. Press close, check beam continuity, press OK, press close, run the analysis, press OK. Now we have to import the terrace level, stair cabin level plan. Save the plan, click millimeter, click OK and select the SC slab level plan. As you can see, the column has not been generated and this point is being seen as 0 0 because it has not created the plan at the reference point, making it a 0. So this will not be acceptable. We have to change the SC level plan to make sure that 0 comes same at all the floor levels, right? So let's just see. As there is only a column, it has not been imported. So let us draw a dummy slab, right, and save this as DXF. You have to make sure you have to place a dummy slab also in order to import the same in Planwin. Let's just import. This plan is not needed. Press millimeter, press this, press SC slab, press OK. So this slab and column are not needed, right? So just delete it. And now as you can see, the level or say the points has came perfectly. All you have to do is you have to go to design parameters. This shall also be roof. Everything else is same. Analysis with continuity, press OK, go to beam, auto beam. The depth is OK. The internal beams height shall be 1. Sorry, in this case there shall not be height. There shall be height here only, and everything rest is same. Let us see whether UDL has came. Yes, UDL has came. You have to see the property of this only. You have to change the floor finish and live load. You have to. There is no continuous beam, so we do not need to check the continuity analysis. Run the analysis, press save and make it a SC slab level, right? As you can see, all the floor plans has been completed. The floor analysis has been completed. At this stage only you can see whether the beams are failing or passing. Now we shall create the 3D frame model using Framewin. In order to generate the 3D frame model, you have to go to File and launch Framewin, or you can start the Framewin from the external window also. Our level shall be plinth level, GF slab level, first floor slab level and stair cabin. That is 4 levels are there. So 0 to 1 shall be plinth level, then shall be GF slab level, then there will be first floor slab level, and then there will be SC slab level. At any point of time, if status shown cross, you have to run the analysis in the plan of Planwin. The plinth level height shall be 1.5 meter, rest seems okay, this shall be 3 meter. Right? Why this height has not come? Because we have given the FF slab level also as roof level. Our grade shall be 250. We have to copy the same to all the levels below and we have to press OK. We can create full frame structure or we can create part structure. Let us save it to 3D. As you can see, let me show you 3D orbit, and the floor has come completed. As you can see, the 3D model has been generated perfectly. Level information. If you do not want to create the full 3D model, we can just press this so that we can just see that there are full column to column beams as full and secondary beams as a temporary beams. We can do this to make this full, but let's just have it the way it is. It's our practice to see everything, right? Now all we have to do in Framewin is to design the columns, design the footings, and generate the beam column and beam column and footing reports, right? Let us just do the column sizing. Press column sizing. It is asking us for everything. Auto size the column. Press auto size the column and you can see it will calculate the column reinforcement as well. All you have to do is you have to just make sure the fixed size shall be what? Minimum difference above and below column shall be of 0.150 or let us say 0.075. Start column depth shall be 0.3. Minimum column depth allowed is let us say starting is also 0.23, right? So it will increase the size by 0.75 mm and check for the reinforcement. We can give extra loads to take effect of the seismic loadings. Let's say we are just designing it for 50% extra dead plus live load. Clear cover shall be 40 mm. Diameter link reinforcement dia shall be 16 mm. Effective cover is calculated, steel grade is given, and we can design. If you want to maintain the size, just change it to Y. All the size shall be same in this case. Auto size for column are set. As you can see, the sizes of columns has been calculated. Now let us see the structural GA. These columns are of vertical and not horizontal, right? All the columns are of vertical size. So we have to go to Framewin, we have to select these columns and we have to make sure, give them the indication that at this line there shall be this point and we have to update this. As you can see, the column has been updated. We have to do the same. At this line there shall be a vertical edge. Let's select these columns. At this line there shall be a vertical edge. Select these columns, select this line, select this line and the vertical one. This is coming as 230 by 230 and it is okay in 230 by 230, but if you want to change the depth to any other, you have to just click on size and you have to change the depth from here. Let's make it 450 also, because we want it to be of 230 by 450. Okay, so we can change it from here only, and as you can see it shows you everything. The reinforcement required, the governing case is axial and everything. The cumulative load also can be seen. Press OK, select the beams, angle shall be yes. Now it should come perfect. Select this line and press OK. As you can see, everything has been seems completed. We have to change this too. Select this, select the line, select the orientation. As you can see, all the columns has been generated. We do not need to go back to this. We have to save this, we have to close this. Now go to estimation and footing for footing design. It is asking for the plinth height, loose the type of soil. In our case it's a hard muram and PCC grade. It will design the footings by default and press OK, and it will be asking us to design whether pad footing or trapezoidal footing. We want to design pad footings. The total height and rest of the data, let us have them same. Change the FCK and FY. Concrete univeight, equal overhang, yes, and press OK. As you can see, the footing length and width has been created. You can edit the footing data at any point of time if you wish and generate the report. It is asking that the file is already there. You want to override or not? Press yes to override the same. As you can see, the footing data has been generated. So we have now the footings. Press OK. As you can see, the footing has been seen. Go to estimation again, create on the column, and as you can see, the column data has been generated. Generate the report, press OK, and the column design results are there, readily available to you. As you can see, the column design result has been generated perfectly. Close this, press OK. Now go to estimation again and click on beam data. It gives you all the beams still at top and bottom also. Stirrups are also being seen. Click on generate report, press yes, and the report will be generated. Now you have all the design data, that is the reinforcement requirement at each level. As you can see, level wise reinforcement requirement data is there. So you have completed the modeling, analysis, design and report generation using Planwin Framewin. Thank you for watching this video. Do like, share and subscribe the same.